Hello, good evening all. So is my screen being visible to all? Okay, I think it's fine now. So yes, I'm sorry I had few technical difficulties. Don't know what that was, but I think it's all sorted out now. So yes, Raj Kapoor, yes, Tulasi. Good evening, hello. So it took me some time to get it done. So I think we are all good now, and even my audio is also coming right? So yes, so I think we should start off. Yes, good evening, Anu Bunikut. Oh, Anu Bunikuten. Good evening. So I think we should just start off with the class already because it's already 8:40. I wasted some time with the OBS system and all. So yes, today's class we will be discussing about geography, and I even had a few sessions before. I think one and a half, probably just 2 months before, I had few sessions in geography as well. And if you haven't watched that, do click on that. There were live sessions, and today will be also geography, and we will be discussing about structure and the atmosphere has varies of layers and structures in it. So we'll be discussing all that, and yeah, thank you so much. Yeah, so we'll start. So yes, so I'm sorry if my network is not very good and if it's buffering. Okay. So yes. So like we all know, for example, if we are talking to example, for example, medicine. This is just a small medicine. It's an alcoholic-based homeopathic medicine. So we know what's the compositions of it. The descriptions will be given over here. The same way also, even the atmosphere, it has various of compositions in it, and because of the density, for example, some part of the oxygen will be more denser, and some part of the atmosphere will be less denser. So they'll be floating above and below, and they will be having lots of layers, like stratified layer. So we are going to discuss all these, horizontal layers of atmosphere. But before that, we need to understand what weather and climate is, because more often students tend to be confused with what is weather and what is climate. Weather is basically what happens in a day. So, for example, if today is, it's raining so much today, but tomorrow it will be very sunny. So it keeps changing. But climate is something, for example, what is the climate of here in India? India is mostly a tropical nation, and it's here it's mostly sticky and hot and humid. Okay, so that is the climate. But if you ask weather, we cannot just classify it. For example, even in a single state, for example, Tamil Nadu, it will be very hot, but in some places like in Himachal and all, it's very cold. So there's disparity, and for those reasons we cannot generalize weather. And even for a single state, for example, in Delhi's weather will keep on fluctuating from day to day, and sometimes even just within the day. Probably morning it will be very cold, and evening or the afternoons will be very hot, and night again it will be very again cold. And there's no guarantee for weather because it just keep on changing. So the definitions over here is very clear. Dated weather, for the weather, okay, I'm explaining day to day changes in the state of the atmosphere. But climate is that is the weather conditions taken for a larger period for 30 years. So since it's longer period, the average is being taken care of. So that's how we get weather. And what is atmospheres actually? They are the gaseous. For example, if we say that what composed the surrounding us, just imagine sort of like a blanket. Okay, a blanket or a glass kind of like a ball is being encapsulated inside outside a earth and within the glass. For example, this bottle. Okay, this bottle having a water and the atmosphere inside. So same way, even for a earth. Imagine earth having a big giant, a glass enclosure outside. So they will be holding lots of atmosphere and gases and all these. And we have atmosphere in earth, and also there is a different kinds of atmosphere in moon as well, and each of them have their own atmosphere. We cannot say since atmosphere is mostly associated with oxygen doesn't mean that moon wouldn't have atmosphere. It has a different compositions of it. We have abundance of oxygen. Some other planets will be having their own compositions of atmosphere. So here it's written that atmosphere is defined as the gaseous envelope that surrounds a celestial body, and it couldn't just be just earth, any part of the planet. even an asteroid or even sun has an atmosphere in them. Okay, they have heliums and all, and it's radioactive fusions that's happening over there. So they have their own atmosphere associated with them, and therefore Earth, like the other planets in the solar system, has an atmosphere which is retained by gravitational attraction and largely rotates with it. And since these gases, we all know, they tend to just go around and they cannot be encapsulated in a year. But since we have the glass sheet over here, glass sheet, for example, this is the Earth, and we have a glass sheet surrounding them. So imagine like that. But instead of that, what is that we have in real? We have a gravitational force. The gravity is being pulling even the atmosphere outside, that is keeping themselves within. And for those reasons, we can say even the atmosphere is rotating with the Earth when it's revolved around the sun. So that's what's happening over here. And who studies the atmosphere? Learning about different states of atmosphere enables science to understand and predict changes on the ranges of scale. That is about these climatology, weathers, and all. And meteorology is the subject that studies the chemical and physical properties of atmosphere together with its field of motion, mass, and moisture. And these are just the definitions. And how was it formed? That is, how was all these oxygen and everything was formed here on Earth? How do we have what the present situation that we have now? How was it formed? Like all of a sudden, what happened? Oxygen came here? No, that's not like that. It was years. That is, for example, millions and millions of years formation that led to this process. And slowly by slowly, it got modified and retained, and that's got it refined, and that's how we get oxygen. So it's like the first stage in evolution of Earth. It was actually an oxygen free environment, and we know that the whole of the universe, it's not just Earth, everything exploded from a big bang. So this is sort of like a theory, and it's not, I cannot say it's been like an established fact. It's still a theory and still debatable. So it is to be believed that Earth was actually a very hot kind of a ball, and there can never be any life sustenance over there because it's very hot, and the atmosphere compositions was far different from what we have now. So slowly by slowly, like how the life evolved to us to be like a human, same way even the oxygen, it went through, and the atmosphere, it went through series of evolutions, and that's how we have oxygen over here. And that's how it's written over here. How so for example, we cannot say that one person starts creating oxygen, the other person, it's all whatever is being made in Earth, it's also been retained here in Earth. For example, when people say that because of lots of contaminating the air, and it's polluting the air, and it's like making lots of boring lots of holes in ozone layer. And I don't think this is very much true, because the reason is that whatever is being made over here, it is also being retained over here. For example, water, if I would say a very clear example, I would say is that, for example, a water. I use water, and when I drink the water is no more. But it is, occurring in me. It is there in me in a different form. It is now in sustained in me in different form. And when I have my own children, my children, they will also be having a part of the water or the food that I have. So whatever is being made over here will only be, perish, and it will be here. It's sort of like a recycling. And for example, when I die, okay, so how do I die? My body will decompose. So whatever all these proteins, water, or minerals that I accumulated throughout the whole series of my life, I will be giving back to the to the earth if I'm being buried, or if I'm being just burned. It will be giving out to the atmosphere in different forms, different compositions. Just because it's in different chemical structure doesn't mean that it's being destroyed all of a sudden. It is being converted to different forms. So just like that. And I don't think, like I said again, this will be sort of like being destroyed, because it's a vicious cycle. Probably it would cannot be renewed now, but probably millions years later we can renew it again. And compositions of the atmosphere of the earth is that we have 21% of oxygen and 78% of nitrogen, and we have 1% of other oxygens, I mean other gases. And nitrogen or N2 78, and oxygen is 21%, and argon is like Ar, carbon dioxide, neon. So these are the minor part of the composition. These whole compositions comprises with just 1%. The majority here goes for nitrogen, and the other second position goes for oxygen over here. And vertical structure of atmosphere is that We have thermosphere, mesosphere, stratosphere, and troposphere. So one way I learn all these difficult terms because they are factual and they have no meanings associated with them. So I do is that tropo is like topography, so something related to land. So this way it's easier for me. So it's like T at one end, T at the other end. So there has to be after T comes S. So like for example in ABCD alphabet, like it's like ST. Okay, so something like that. I remember like that. So troposphere, stratosphere, mesosphere, and thermosphere. And we have other minor layers also here in between. That is tropopause, stratopause, and mesopause. So these are more like transient phase. For example, from mesosphere to thermosphere, we have a transient. Okay, sort of like an overlapping phase or a layer called mesopause. Okay, if you have any doubts, do let me know that in the comment sections. Okay, the atmosphere divided broadly into four categories, but we cannot say, for example, troposphere is 10 kilometer over here, and we cannot say this rule applies to what whole part of the earth because in some place it will be 10, the other place it will be probably 15, in other place it will be 8. So it keeps on varying, and we cannot, for surely say troposphere is actually correct exactly 10 centimeter or 10 kilometer here from the earth. We cannot claim that. And each layer is characterized by a uniform change in temperature with increasing altitude. And in some layers, there is increase in temperature with altitude, while in other decrease in, for example, here it's like alternative, and that's how I understand. From here we go, it's like the more we go up, it's colder. And some place, what happens? The more we go, it's like from colder to hotter, and some layers again from colder to hotter. So that's how it is. The top or the boundary of each layer is denoted by pause, where the temperature profile abruptly changes. That is, like I said, this is a transient phase. And from troposphere, this from this point onwards, it totally takes a 360-degree in terms of the temperature. So troposphere contains about 80% of atmosphere. Why? Because more of gravitational pull, and since the gravity is pulling here all together, the all the denser. What is denser? Oxygen and all. So since these are denser, these tend to stay here in the first layer itself. That is in the troposphere. So troposphere contains 80% of the atmosphere and is part of the atmosphere in which we live. Like for example, like I said, topography, troposphere, and make weather observations. In this layer, the average temperature decreases with height. For example, if you go to Kunu Manali or Uti or in some places that you must have observed that as we go up, the temperature it falls. The more we go up, it tends to be more cold and cooler. So there's less air in contact with the ground to heat, and this is known as environmental lapse rate because it's not just about the gravity. For example, we know what's inside the earth. Inside the earth is a hot or the hot magma that we can find, and it is to be believed that the outer surface of the earth's temperature is same as the innermost core of the earth. So as we go away from the core, that is away from the ground level, it will be losing the heat also. So same way, it's all connected. So as we go up, we are sort of like losing the touch with the heat and hotness. This sphere mixes vertically by conduction, and turbulence more than any other sphere. These vertical motions and the abundance of water vapor makes it home for important weather phenomena. Troposphere is around 16 kilometer high at the equator, with temperature the tropopause around minus 80 degrees Celsius. At the poles, the troposphere reaches a height of around 8 kilometer, with the temperature that is, like I said, for example, like in some places the height or the distance with the troposphere and the level ground will be shorter. In other places, it's very hard. For example, we know that Earth is not an exactly round. It's sort of like a geode sphere. That is, the top are flattened, but the equator side it is bulging. So since they are bulging, we can say that these in the equator it will be 16 kilometer high, and here that we say is that it's 8. Found it somewhere. Okay, I'm sorry, I lost the sentence. Okay, in the poles it is just 80, and yeah, and like I said, the more we go up, the more cooler it's get, and we start losing the temperature, and also the gravitational pull also will be decreasing as we go up. So that is how it's sort of like inversely proportional. The more we go up, the more temperature will fall down, and the density. And next atmosphere or the next layer is stratosphere. See, we have over here, this is like the first one, stratosphere, troposphere, and mesosphere. So troposphere is where we can see Mount Everest, and also this association with all these landforms and everything. So we are here, and the next phase or the next level is stratosphere. Here it's different. Like we said, as we go up we find a fall in temperature, but as soon as we reach here we find that the temperature starts increasing drastically. When we get here, it just abruptly shifted and the temperature just increases. That is, it start getting more hotter when we go up. And it's caused by concentration of O3. O3 is actually the ozone oxygen, that is carbon monoxide, which absorbs the ultraviolet radiation. Since the radiation, it stops over here. For example, just imagine this place to be a sort of like an concave kind of a mirror is kept over here. And what happens? This protection is absorbing all the heat, all the radiation from the earth. Since they are absorbing, all the heat is being generated here on the earth, is being taken inside, it's being sucked over here. So in this cases, as we go up, we'll find the temperature just increasing so much. And temperature range from 30 degree over to the winter poles to 20 degrees. That is, in equator we find 30 degrees Celsius, but in the pole, that is on the polar side, we find this 20 degrees Celsius higher. And as well as noticeable change in temperature. The move from troposphere into the stratosphere is also marked by an abrupt change. Like we said, here it's very cold, but all of a sudden just start becoming hotter. Water vapor decreases sharply while ozone concentration increases. Why? Because the also ozone, absorption layer is over here, sort of like a sponge is over here. So since the sponge is absorbing all the radiations and heat, we'll find that. And stratosphere extends up to around 48 kilometers above the surface, and together with the troposphere they account for 99% of the earth's atmosphere. And all the life sustaining atmospheres here in troposphere. But again, why do we say some components are still there in stratosphere? Why? Because all the radiations being generated here in the earth are being taken care of, or being sucked or being absorbed here in stratosphere. So that's why we say even some part of the atmosphere is also being composed here in stratosphere. And the next layer comes mesosphere. Again, the temperature changes. Okay, the temperature in mesosphere decrease. So here what happens? The cold increase or the temperature decrease, and here the temperature again increases, but here again temperature falls down. So temperature in mesosphere decrease rapidly as there is no water vapor, cloud, dust, or ozone to absorb the incoming radiation. Incoming means from here, from the outer space. Okay. And as in the troposphere, the unstable profile means the vertical motions are not inhibited. During the summer, there's enough lifting to produce clouds in the upper mesosphere at high latitude. That mesosphere is where all the meteors happenings. Okay, so they are very much far away. That when we are standing here on the earth, when we find all these meteors and meteorites passing, so that is where the mesosphere is there. In this mesosphere only where we find all these meteors and all. And since they from here we can say, and outside stratosphere we can say, this from here onwards it's space, the intergalactical space that we can say of. So space is generally associated with very cold, since why they don't have atmosphere by themselves, so that's why we say it's very cold. And thermosphere extends upward to altitude of several hundred kilometers, where temperatures ranges from 250 degrees Celsius to high as 1700 degrees Celsius, getting warmer with increasing height. And why do we say that? Why? Because we have an important component over here. What is that? Sun. Okay, no matter wherever we go, we have the important component here at the end of thermosphere. Since we are always rotating and revolving around the sun, so our extent ends here at thermosphere. All right, and temperature range depends and temperature ranges depend on the degree of solar activity, as there is more atomic oxygen there and to absorb heat. And the temperature change between day and night amount to hundreds of degrees. That is, even from the difference of day and night temperature, we can find hundreds of differences in terms of temperature. Above 500 kilometer temperature are very difficult to define. The molecules are so widely spaced that they move independently. There is no reason why their temperature should be the same. Yes, like as we know, why do we say this is the matter? This is a solid matter. Why? Since all the molecules are composed together, they are tightly packed. So here we can identify it and everything is being clearly defined. But here we cannot say. Why? Because it's space. Since we are done with stratosphere, from mesosphere onwards we can say it's complete space, and from mesosphere onwards, and that is from the end of mesosphere and the starting of thermosphere, it's totally we are going towards the sun. So and Earth's annual heat budget, that is heating of the atmosphere, uh, like we all know that India is a tropical nation, and also among the equator, all the nations or all the places that's been marked here in the equator are generally very hot. Why? Since they are directly being at the source of direct sunlight, and they are directly falling on us. What happens here, the north and southern poles, they are being slanted, or the rays are being slanted to them. Because why? Earth is not here. It's like something like this. It's rotating on the axis, not on a straight line, on an inclined imaginary axis. For those reasons only, okay. And at B, that is B on the northern poles, sun's energy is spread over wider surface area, leading to less directing heat. And yes, so this is the radiation budget in chart and all. So depending upon the latitude and the energy levels, and the heat budget in our winter. Of course, Earth heat budget is not that simple. You have to remember effects of seasonality, the season shift in the trace of sun on the Earth's surface during its orbit. Like we have summer season, monsoon season, winter seasons, and I think in mostly other European nations. Why? The reason is that their climates are not very extreme in comparison to here in India. We can't say it's snowing in winter season. Why? Because we are closely here to the equator. It's almost like we are touching the equator. For those reasons, our climate will be generally the same. But over here, since they're inclined in the next season, for example, if this is a place here during one season, the next season they'll be here. So it's sort of like being away, directly away from them. And yes, and Earth's annual heat budget is that. So over the pattern of year, the Earth's heat budget changes with the seasons. However, there's over surplus at the equator. Why? I would say suggest that, for example, here in India, except for in some nations, in some countries, and I cannot take examples like Himachal Pradesh and Shimla and Delhi during the winter seasons, because we have an influence of the Himalayan mountains. Because of Himalayan mountains only, it's cold over there. Otherwise, since we are closer to equator, there is no chance for us to have any forms of cold climate over here during the winter seasons. It has to be. If we wouldn't have, or if this Mount Everest or this Himalayans wouldn't have been there here in our Earth, it would have been totally most of the seasons or throughout the year, the seasons or the climate would have been same throughout whole of India. Because why? Because we are near the equator. And the uneven distributions of heating across the earth is what drives air to move. And we all know the wind moves depending upon the density. And what happens, for example, if there's a vacant space over here, what happens? People come and stay over here. Same thing here for the wind. I'll talk elaborately when we're talking about the wind systems and all. That is, when the density changes, the wind will also move its course. Because why? Because the earth heating is very much uneven and it's not distributed. And when one place is heat or one place is being hot, the other will be cold comparatively. So for those reasons only, the wind will be passing from this place to the other, and the wind also have a course, and they have their own patterns and seasons according to it. Hello, Sankalp. Yeah, so we have more people joining here. So unfortunately, we are at the end of the class. So today's class was very short. Tomorrow, I'll be talking elaborately about the wind systems and all the trade winds and all. And I know it's pretty much students, but if you have the concept, that if you understand all these, okay, so what happens over here? If you have a general idea, it seems to be very simple to you all. And today's class was just giving you a brief understanding of all the layers that we have in our Earth and in our systems. So we just have four layers and other three sub layers. That is the transient layers. So these three are transient layers, but the main are the four layers of it: troposphere, stratosphere, mesosphere, and thermosphere. So that's it for today's class. And if you have any doubts, do let me know that. Or you could even leave in the comments. You don't have to leave in the live chat itself. You could leave in the comments. I would, read that and do accordingly to that. So tomorrow's class will be extensively about the wind and the patterns of it. So, and one more thing is that I will be giving out all the PPT slides in my Telegram channel. But apart from that, you should also make notes by your own, because there's nothing like handwritten notes. You could have lots of study materials, you could buy all the materials from the world, but that wouldn't, take place of your handwritten notes, because when you write something, it will be, it makes more sense to you than just reading it. For example, you have the concept, when I explain it, you understand it, but few days later, if you just read the same PPT slides, you can't even remember. But it's not the same thing for handwritten notes. Suppose you just write it today, even if after 2 or 3 months you read it again, you'll remember everything, because you exerted your effort into it. So because of that reason, likely that you will remember it more. So that reason why, even though I'll be giving out the PPT slides in a Telegram channel, you also have your own study materials and make your handwritten notes. So yeah, thank you so much, Raj Kapoor Das. Thank you, all the students. So that's it for today's class, and we'll see you tomorrow at 8:30. We will be discussing about the winds and all winds